Hello and welcome to the Maine GIS Users Group Virtual Lunch and Learn for December 8th. This is about our 6th or 7th that we've done this year, so we're really excited to be able to present another one. We've been doing these mostly on a monthly basis. I'm Patrick Cunningham, and along with Jamie Carter, we will be your moderators for the Lunch and Learn today. Hopefully everybody can see my screen and can hear me okay. If you can't, if you're having a problem, please let me know. All attendees are currently in listen-only mode, but if you do have any questions or anything to share with us or presenters at any time, please just use the questions panel and we'll do our best to answer them and address those issues. We're excited today to be hosting this lunch and learn on high resolution land coverage and forest mapping for Maine with guest speakers from NOAA and the University of Maine and the Maine GeoLibrary Board. Just a word about the Maine GIS Users Group. MEGUG is a nonprofit organization that promotes awareness of and encourages the coordinated development and effective use of geographic information and related technologies. MEGUG focuses its efforts in the areas of policy, liaison, networking, research, education, and public relations. The group facilitates discussions and exchange of information and ideas in these areas by hosting regular meetings, workshops, and roundtables open to both members and non-members. And as you know, this year with COVID-19, we pivoted to doing these meetings virtually. The MEGUG board is comprised of the following folks that are listed here. I'm currently chair, and Judy Coley-George is our current vice chair, Jeff Normandin and Andy Smith-Peterson, joined by Becky Schaffner, Don Katnick, Taya Youngs, and our newest members that were just elected, Matt Doobie from the University of Maine and Laura Tessel from Sewell Company. I'm very excited to welcome them on the board. And we'll be meeting in a few weeks to appoint new officers. So some of this will be changing. As you can see, our education coordinator is TBD, as Tori Johnson is no longer a member of the board. But even if you're not on the board, you certainly can be involved in MEGUG. We do have committees, and we always are in need of help. Certainly education, promotion, and coordination and communication are some different committees that we have. So education and promotion are probably pretty obvious. If you're in the education area and you want to participate on that committee, we'd love your help. If you want to help us promote Maine GIS User Group, if you're good at social media or internet or what have you, marketing, we would love your help. And if you're interested in our programming, presenting a virtual lunch and learn, we are in need of speakers, or helping us plan for when we one day can get back to face-to-face events, we could certainly use your help. For more information on that, you can just visit megug.org and send us an email at megugboard@gmail.com. And for our upcoming virtual brown bag lunch and learns, the next one we have slated is in January on the 12th. If we can't do it, you don't need it. Retail GIS with Rob George, Director of Market Research for Rite Aid. And I believe he'll be talking about, optimizing the location of retail GIS and sharing with us different mapping challenges that he does for his work at Rite Aid. And then, as I just said, we're in need of other presentations starting in February. So please do let us know if you have any interesting ideas that you would like to present. It doesn't have to be a long talk. Usually we do about 30 minutes with a lot of questions and discussion. And we certainly would love to hear from you. And once we've finished the presentation, we do post it on our YouTube channel, and we've got about 5 of those up there now, maybe 6, I'm not sure. But definitely visit megug.org to flip over to our YouTube channel to watch past presentations if you've missed them. So now I'm going to hand it over to Jamie Carter to introduce our speakers. Jamie?
Thank you, Patrick. And thank you everybody for joining us today. My name's Jamie Carter with NOAA's Office for Coastal Management, and I am here in Maine. I am a regional geospatial coordinator, and I work uh, on behalf of NOAA and all of our geospatial constituents throughout the Northeast to make sure that geospatial technologies are being used as effectively as possible and to understand what we can do better. And one of the things that we've heard over the last several years is the value in land cover, forest mapping, wetland mapping, and how traditional 30-meter Landsat-based imagery provides very useful products, but the resolution of those products is typically a little bit coarser than what we need for local level management decisions. And so a couple of years ago, we started talking at the state level with a variety of partners to determine whether or not we needed to revisit land cover data and mapping efforts here in the state of Maine. And it was at that time that the Geo Library was investigating whether or not a new framework data set focused on land cover would be appropriate. And through the leadership of Joe Young and others who were involved in those early discussions, we got to know the folks at the University of Maine and put together a proposal that we're going to be talking about today. And the proposal is to develop a suite of land cover products. So we're going to be talking about both a 1-meter resolution land cover product that's consistent with the National Coastal Change Analysis Program data that come from NOAA. And we're also going to be talking about a 10-meter product that is based off of the NOAA data, but provides much more detail for forest types and disturbance as well. So I'm going to let our two speakers dive into the details, and I just want to introduce the two of them, plus Claire Kadrowski, who's going to be wrapping up our presentation today. So our first presenter is Nate Herold. He's a physical scientist with NOAA's Office for Coastal Management. And he's based in Charleston, South Carolina, but he's online today, and he is responsible for leading NOAA's National Land Cover Monitoring activities through CCAP, the Coastal Change Analysis Program. His work includes improving mapping efficiency and accuracy, oversight of land cover task order awards, coordination of partnerships at local, regional, national scales, and looking at things like modeling potential wetland impacts from sea level rise. Then after Nate, we're going to have Kasey Legaard. Kasey is a research professor with the University of Maine Center for Research on Sustainable Forests and the School of Forest Resources. His work revolves around satellite remote sensing of forest resources. And as the project leader for the University of Maine Intelligent GeoSolutions Group, he is responsible for the design, implementation, and execution of machine learning methods to improve forest maps derived from satellite imagery. So between the two of them, you'll be learning a lot about the two products that each group independently works on, and you'll also learn about the collaboration between the two organizations, and we should be diving into some of the techniques and the methods, the geospatial methods that are being leveraged to actually develop these products. And Claire Kadrowski is the executive director for the Maine Library of Geographic Information, or the Geo Library, at the state of Maine. Claire has a long history of working in the geospatial space and is going to be discussing with you a little bit about where we are with this program and where we want to go with it. And so she'll be kind of closing things out. Throughout the presentations, I encourage you to enter any questions you have in the chat. You should have a chat window available to you. So please pepper us with questions, and we'll try to handle those at the end of the presentations. So with that, I want to turn it over to Nate Herold.
Thanks, Jamie. All right, perfect, thanks. Appreciate the introduction, and as Jamie said, I'm going to be first up here to talk a little bit about some of the higher resolution land cover that we're proposing as part of this work. So hopefully you all are familiar with NOAA's Coastal Change Analysis Program. If you are, you're probably most familiar with our 30-meter data that Jamie gave a little bit of an introduction on. This is products that we've been producing from Landsat imagery for decades. And while we're primarily focused in the coastal portions of the country, We've been sure to update those products on a 5-year repeat cycle and work very closely with other federal agencies like the USGS in producing one seamless national consistent product and making sure that our CCAP data is incorporated into our NLCD data sets from the USGS. And that's important because it shows that while the data sets that NOAA is producing are coastally focused, that we're tying those into these national efforts. Just to give you a little bit of an update, if you weren't aware of where things stand with those products, we recently released a 2016 update. We did that earlier this year in March of 2020. And we're getting geared up to do a 2019 update in early 2021, again, based on those NLCD data sets. We really hope that in a lot of ways that this becomes one of our last 30-meter products. Really where we see the future of CCAP data is in producing more high-resolution data sets, which we're going to talk a little bit more about here. High-resolution versions of our CCAP data is not something new to us, but it is something that we have had very limited geographic scope in terms of how much of that data we've been able to develop in the past. And a lot of that has been due to the cost involved in developing those products. As you can maybe understand, developing land cover at a 1-meter resolution isn't anywhere near as cheap to produce as producing the 30-meter products that we've produced in the past. And while we've seen that change recently, change enough that we really are starting to try to move in this direction through the advances in terms of improved technology with cloud-based and distributed processing, more freely and cheaply available data sets, imagery, LiDAR, and whatnot. We really have seen the costs start to drop, making the development of these kinds of products faster, cheaper, better possible. And I caveat that statement with the fact that while we can produce them faster, it's not as easy as just clicking a button. While we can produce them cheaper, it's not as cheap as producing the 30-meter data. It's still an added cost there. And while the data sets certainly are better than what we've been able to produce in the past and better than the 30-meter data, it takes a lot of work to get there. Right now, you can see in this graphic, these are some of the areas where NOAA is working to stand up some pilot geographies. And we're hoping to work with folks in these pilot geographies to convince them of the power that these higher resolution data sets can provide them, and get them interested in helping us to build out this data set nationally. And what we're really trying to do is target kind of a 2019 to 2021 era of mapping based on the imagery that might be available for any of these coastal areas, and have that complete by 2025. And at that point, it would be our goal to start operationally updating those products. So what we're really talking about is moving from data that's produced at a scale like this one with our 30-meter data to data that can be used at a much more local level to support more local parcel-based analysis. This is one example of a product that we recently completed for the state of Connecticut. Now, normally, I would spend the next several slides comparing some of this type of high-resolution data that we're producing to some of the 30-meter products that we've produced in the past. But I think Maine is a little bit more familiar with some of those higher resolution data sets than others. You know, with the work that you all have done in the past and that we've assisted with in the past in producing some of the MELCD data sets, that's a great example where you all have already recognized the power of those kinds of higher resolution data sets. So instead, what I'm going to do is spend a few slides highlighting some of the examples of draft products that we've been producing in York and Cumberland counties, and compare those to some of the imagery and MELCD data sets that exist for those same areas. So, you know, what we're hoping to produce is high resolution data that could be better used to support improved hydrodynamic or water quality modeling, more detailed flood risk assessment or stormwater management activities, or might be used to calculate open space preservation credits as part of FEMA's community rating system. This example south of downtown Biddeford is just one example that highlights the level of detail that we're able to bring in the development of those products in a developed area. And hopefully you can see here kind of that very detailed impervious surface information that comes out, the impervious cover category there being highlighted in white. And you can compare that to some of the past MELCD products that have been available for that same area. And unlike the MELCD, you'd be buying into NOAA's CCAP product line, knowing that NOAA has a vested interest in not only producing this product in the short term, but also in keeping this data up to date on a regular cycle. Our goal after building out the product statewide would be to update this data every 4 to 6 years based on the availability of imagery and resource funding that's available. Here's just another example that also points out some of the usefulness in the data for urban forestry applications. So not only is the impervious itself more detailed, but a lot of the other features within those developed areas also have a lot more detail. This could be highly useful for looking at green space applications, air quality issues, urban heat island impacts, and essentially just looking at the data that we can produce now at a much more local level compared to either the 30-meter CCAP or that MELCD products that have been produced in the past. And we also have the ability, while it's not part of the explicit proposal here through the Geo Library, to potentially offer even more detailed impervious mapping. One of our contractors, a company called Ecopia, utilizes an ensemble of neural nets to classify a suite of impervious related categories. 6 categories at a minimum, up to a dozen for those that have a little bit more interest in a few others. Things that include roads, sidewalks, railroads, as well as the center lines associated with those features, buildings, driveways, parking areas, and several other additional categories as a possible buy option. Now, the products here are not necessarily perfect. Canopy and shadow can still cause an area issue in some areas, but the products and the neural nets that this company has been using have been pretty impressive in terms of the level of detail that they can provide. We also want to see high resolution data that could be used to better support green infrastructure analysis, better conservation or restoration site planning, habitat assessment, or carbon accounting. This is an example in the Wells Harbor area west of Drake Island. And you can just see here both the level of detail that exists in terms of how we have captured the channels and the tidal creeks within the area, as well as some of the pans and pools that form within that marsh surface. And that's just a level of detail that you cannot see with 30-meter imagery. And again, you can compare that to some of the past MELCD data, which also suffered from the same problems of utilizing a lot of that 30-meter Landsat imagery and not providing anywhere near as clear of a look at some of these features. And then just one more example, and I'll note that one of the advantages that we really see in this data is that we hope to be able to make the products that we produce much more widely useful, both for typical land cover related applications, but also in feeding applications that maybe didn't always rely on land cover. For instance, some of the work that we're doing right now, not here in New England, but in other parts of the country, we're working very closely with the U.S. Fish and Wildlife Service to see whether the data that we're producing at this scale for CCAP could be much more useful in terms of updating the Fish and Wildlife Service's national wetland inventory data. So we see a lot of advantage or potential advantage in producing not just land cover products, but wetland related products and impervious related products that could be used in a much wider context than land cover has in the past. And there's a couple of really nice connections that we can make. CCAP is currently the basis for the coastal wetland component of the US greenhouse gas inventory. And so by making some connections at the national scale with that carbon accounting and bringing some similar connections at the local scale to places like the wells near, we start to have a very powerful bottom down and top up approach to some of these problems and applications. And again, we do have the ability to offer for folks if they have interest in potential additional funding beyond what we're talking about just for this state land cover based proposal, either now or in the future, the ability to do more detailed wetland habitat mapping. This is something that we've done in the past with both Rhode Island and New Hampshire. The 2012 Rhode Island data is available in their website, and the 2013 New Hampshire data is something that's available in our Digital Coast website if you'd like to visit that site and take a closer look at some of those products. And so in summary, I'm hoping that I've piqued your interest in contributing to some of the high resolution data, land cover data that we could be producing for the state. I'd be happy to talk with folks and answer questions, both related to the land cover itself, but also some more of those additional buy-up options that might be available. And as a way to kind of transition into Kasey's presentation, I would just like to note that the 1 meter data that we'd be producing would be the foundation for the 10 meter products that he'll be talking a little bit more about. Essentially, we would be resampling that data up to 10 meters, and that would provide the non-forest related feature mapping at that scale. And then I'll let Kasey obviously speak to more of the detail associated with some of the forest mapping in just 1 second. And I'll close up to just give you the couple of URLs that point to our CCAP data now. And just note that one of the things I know I didn't really speak to was the schedule that might be associated with that work. And the primary reason for that is that it would be highly dependent upon when the funding came in. But that my suggestion would be that if we were able to get the interested folks and the funding together over the next several months and before the end of the coming calendar year, that might be perfect timing to take advantage of some 2021 imagery collection that we know is planned and could provide a really great, very up-to-date product line for the state. So with that, I'll say thank you and hand it over to Kasey.
Sure, Nate, before we do that, we do have a question as we transition. With increases in spatial resolution, is there any discussion of increasing temporal resolution?
Yeah, so, every 4 to 6 year cycle is kind of where we've landed. And that tends to be about every other imagery collect. Certainly you could think about doing it with every image collect. NOAA isn't likely to have the funding to do that. And if, what we've decided was that to do something like a 4 to 6 year cycle would be a good cycle, and something that wouldn't break our bank. Like I said, if folks were interested in more frequent updates, it certainly could be with additional funding that those updates could be a little bit more frequent, yes.
Okay, great. So Kasey, looks like you've got control.
All right, great. Thanks everyone. I hope you can see my screen all right.
Mm-hmm.
All right, good deal. So yeah, I'll pick up where Nate left off here, and specifically with respect to what we do with that 10 meter product that Nate was referring to. So again, this is the idea being here that NOAA CCAP program would produce this 10 meter data set that's basically just a coarsened version of the 1 meter data. And we would pick it up from there to provide a more detailed picture of what's happening within all of Maine's forestlands. So the NOAA CCAP program itself, that 10 meter data set, there is a beta version that is out there online and accessible right now based off of 2016 data. It includes only 2 forest composition classes. So let's see here. I'm not sure if I'm advancing through the slides here. There we go. Okay. All right. So in the green there, and in the sort of greenish bluish, we've got upland forest and forested wetland class, but there's no additional forest composition information associated with that. So what we are proposing to do is essentially overlay on top of those two classes much more detailed forest typing, including 12 upland forest type classes and 3 forested wetland classes, and then in addition to that, a class depicting recent forest disturbance. So again, this is not itself a forest type map. The idea here is to combine products where we have in one layer, we have 10-meter land cover data and 10-meter forest type data. So in this one product, you would see 15 CCAP non-forest land cover classes, 15 forest type classes. That includes 12 upland classes, as I mentioned before. So here we have 4 hardwood dominant classes, aspen birch, maple beech birch, oak, and red maple. These class definitions are based off of essentially species dominance or co-dominance. For softwood, a cedar black spruce type, a hemlock, a spruce, or a fir spruce, and a spruce pine class. And then in the mixed wood, we have kind of a aspen birch class kind of carries forward into the more mixed wood type, where we have sort of a mixture of softwood, hardwood. And then the softwood classes, the hemlock, fir spruce, and spruce pine would carry into the mixed wood. So these classes were defined based off of an analysis of available forest inventory data throughout the state, essentially looking at what we could do to define and map detailed forest typing based off of available reference data and available satellite imagery. So that's kind of how we settled on these types, and I can speak to the details of that if anybody would like to at the end. But, in addition to that, we would pull the NOAA generated forested wetland type and elaborate on that just a bit by mapping out hardwood dominant, mixed wood, and softwood dominant forested wetlands. This is less detailed because there's just less terrain in that forested wetland type, and we're just generally unable to resolve any greater detail than that really with the available reference data that we have in hand. And as I mentioned, there would be another class, a recent forest disturbance class. That's kind of for a variety of reasons, but the thinking to date is to map disturbance since the 2016 CCAP product. Might wish to change that with the production of a new CCAP product. I don't know. Certainly open to thoughts around that. Okay, so recognizing that we at UMaine are perhaps less well established than the NOAA CCAP program, let me give a little bit of introduction to who we are. I'm speaking on behalf of just a small group of professors at the university who essentially, with the assistance of the UMaine Office of Innovation and Economic Development, kind of established what we would think of as an applied geospatial research and tech transfer initiative. That is the UMaine Intelligent GeoSolutions Initiative or group or whatever you want to call us. The idea really being that we had developed over a period of probably about 10 years through various research grants, a kind of a fairly unique machine learning and geospatial processing tool set directed specifically at forest mapping. And the idea behind IGS was to essentially further develop that so that we could place high quality geospatial data into the hands of our forest industry and other stakeholders. We also work a lot with future forest projections. So a lot of the remote sensing, a lot of the machine learning methods that underlie what we do, we really develop those to better support future forest projections and forest modeling. So we're interested in things like biomass change over time, how the forest is going to look 50 years from now. And in order to produce a better picture of that, we needed a better picture of what the forest looks like now. So that kind of underpins a lot of what we do. Okay, so specifically with respect to what we're proposing here, the way we would get at this forest type mapping is not just simply to predict all of those 15 classes in one shot. Turns out that there's just a lot of error inherent to that process. So what we instead are proposing to do is to utilize multispectral and multi-temporal satellite imagery, and specifically imagery from the Sentinel-2 program, plus a suite of terrain attribute data and climate normal data that we have processed in-house here, combined with the U.S. Forest Service Forest Inventory and Analysis Program field data. So that's something in the neighborhood of 3,600 or so plots distributed throughout the state. Combine all of that using our machine learning methods to predict the relative abundance of individual tree species. So for each species, we would essentially have a prediction at every pixel of the percentage of live above ground biomass at that location that is in that species, if that makes sense to you. So you can see there just a kind of a depiction of 4 little maps for a subset of some chunk of Maine for 4 species. We would be doing this for something in the neighborhood of a dozen or so different species. Again, that plot data, the U.S. Forest Service FIA data, is a huge resource to this end. And we do have access. It's the plot location data themselves are held as confidential by the Forest Service. We do have access to that data through an agreement with the Northern Research Station, and I'd really like to thank the Forest Service for the provision of that data set. So once we have these individual species products, we would pool them essentially to derive our forest types. In addition to that, we'd be using sort of our same machine learning methods to obtain forest change, that forest change class, which would be superimposed over our forest typing. Okay, so why use our methods? Okay, so our machine learning methods were specifically designed to produce improved outcomes from the use of that Forest Service data set when combined with satellite imagery. So here we see a little bit of a picture, a cartoon of what those Forest Service plots look like, or an individual plot. There are 4 subplots, 4 circular subplots. What that looks like on top of, in this case, 30-meter Landsat pixels. But essentially, those 4 subplots sample an area that's something in the neighborhood of 2 acres or so in size. When you combine those small subplots and relatively large footprint of the satellite imagery, there's a lot of uncertainty in associating the 2 data sets with one another, essentially. And you can also see those little gray circles that represent there's some level of location error, both in the plot data as well as in the satellite imagery. So all of that combined means that there's a fair bit of uncertainty in tying any specific forest measurement to the satellite imagery. How that manifests, it sort of depends on where you're trying to get out of it, but for us specifically in trying to predict the relative abundance of a given tree species, that's a regression problem. And what tends to be the case when you pull this kind of data together, those location mismatches and the scale mismatches between small plots and big pixels essentially means that you regress towards the mean. There's what you could call an attenuation bias, where you tend to overpredict at low values and you underpredict at high values. This is essentially the regression algorithm kind of hedging its bets in the face of all that uncertainty and predicting more or less a mean value across the full range of ground measurements. So given all of that uncertainty between field and remote sensing data, essentially there's a trade-off between the total error in your predictions and the systematic error in your predictions. And virtually all machine learning algorithms or statistical learning algorithms try to reduce total error. So this is an example using the XGBoost machine learning algorithm, but you could substitute whatever algorithm into this really. Essentially, it's trying to reduce total error. It does so pretty effectively, but again, partly through the introduction of that attenuation bias. Our machine learning methods are simply designed to draw a compromise or reach a compromise between total error and systematic error. So here's an example of that on the right, where we're predicting the same response variable, in this case, balsam fir percent biomass. Our method, the details of which are fairly convoluted, but basically all we're trying to do is balance the total error and the systematic error. The big effect that has is that we no longer underpredict at the higher values of whatever it is we're trying to predict. And in this case, the impact of that is we see a lot more predominant forestland on the landscape. Now, in addition to that, we use a sort of a two-stage approach for predicting species distributions. If we apply a one-stage, just a straightforward regression, here's a couple examples, one for eastern hemlock and one for an ash species, and it escapes me which one. I think it was green ash. And you can see the results perhaps aren't terrible, but there's a fair bit of, there's a fair bit of slop in those relationships. And you can also note that there's a whole lot of data stacked up on the zeros where there's no ash or no hemlock. If we first predict the occurrence of a species and then on top of those predict occurrence locations, we predict its abundance, we really do a much better job predicting abundance, especially at the higher abundance areas. Now, in this case, there's not a whole lot of high abundance hemlock or ash in this data set, but in those sort of moderate abundance areas, we really clean up the relationships and do a much better job. Additionally, I'd mentioned the change detection approach. We utilize fundamentally the same ideas in detecting change and mapping change, and that is to balance out different kinds of error. We balance out errors of omission and commission. Our methods are highly sensitive, being supervised machine learning methods. They're good at finding change, but they're also good at preventing too much commission error, too much false change, because we specifically tell our algorithms to prevent that, to pay attention to both omission and commission error. Okay, so all of this is supported by software that we've developed in collaboration with the UMaine Advanced Computing Group, so I have to give tremendous credit to them. We run all of our stuff on some combination of the UMaine cloud services and high performance computing services, or their supercomputing cluster. All of our machine learning and map generation software runs on those HPC services, so this is just massively parallelized processing. It enables us to sort of punch above our weight. We're a small group. We try to automate everything that we can when it makes sense to do so. To that end, on the UMaine cloud services, we interface with the European Space Agency and USGS APIs to obtain our satellite imagery. We rely predominantly on Sentinel. We do intermix Landsat because occasionally that additional view at a different time provides good predictive power for species mapping problems. We also, again, incorporate terrain and climate data. We rely heavily on USDA FIA data. We can incorporate other reference data as available. All of that gets sort of tied together by a problem, machine learning problem definition and management code base. And all of that is interlinked with a process management database and process management code that really enables us to automate the process very cleanly so that we can crank out a lot of data in a relatively short period of time. Okay, so I'm going to kind of close with a bit of a direct comparison between what we have in mind and the 2004 MELCD product. I wish I could show you a version of the specific map product that we're proposing. I am trying to complete a sort of a trial version or a prototype, if you will, of the product itself, but I have to do this kind of piecemeal and off hours, so I'm not quite there. What you see on the right is an example of a trial product. We're essentially trying to feel out some of the code involved here. And so we produced this small pilot project. It's just got a very small subset of classes mapped, so 5 of the 15 that we're really proposing. But hopefully it gives you a little bit of a sense for what we're talking about and how it differs from the MELCD. Specifically, there we go. Okay. Specifically, with respect to the thematic detail of the MELCD, the MELCD included 3 upland forest types and 1 wetland forest type. So the upland types were just the traditional, essentially softwood, hardwood, and mixedwood types. We're proposing, again, 12 upland forest types, so much greater detail, 3 forested wetland types, so enhanced detail in that category as well. Now, the MELCD did include 4 disturbance classes, 3 different disturbance intensity classes, and 1 regenerating forest class. We are currently proposing reduced detail in the disturbance classes. The one additional point that I'd like to make, though, is that the MELCD disturbance classes tended to have a lot of omission error. They weren't terribly accurate. With our newer methods and machine learning methods, we can do a much better job of depicting recent disturbance. With respect to the spatial detail, the MELCD is a 5-meter pixel resolution product, but processing and specifically classification occurred at the level of the polygon, whereas we are classifying 10-meter pixels. So I would argue that, in fact, what we are proposing provides much greater spatial detail than the MELCD, and you can see that even here in our small pilot product here. If you look at this one mixed wood patch in the MELCD, you see much greater detail in our pilot. Why this occurs, this is a 30-meter Landsat image for just a small segment of Maine's forestland, just for reference, the 30-meter NLCD, again for reference. So the 30-meter NLCD is produced by labeling, classifying individual pixels. The MELCD did utilize a higher resolution data set to drive the processing, so that's why it is a 5-meter product. It was actually a pan-sharpened Landsat image. Some spot panchromatic data was used to sharpen the Landsat image to 5 meters. That 5-meter data was then segmented into polygons, and it was the polygons themselves that were labeled as a different, or categorized by forest type in this case. And if you remove the polygon boundaries, you see these larger contiguous patches of different forest types. So I guess when I look at this, I see a large contiguous block of softwood, for example, which to my mind, it's fairly questionable whether that's a fair representation of what you see in the Landsat imagery or the pan-sharpened Landsat imagery. So again, I would suggest that by adopting a pixel-oriented approach instead of a polygon-oriented approach, for forest mapping, we can provide finer spatial resolution. Okay, the MELCD had there was no specific update cycle associated with the MELCD. That's why we're still talking about a 2004 MELCD. Here, we would attach the updating of our forest type data set to the CCAP update cycle. So every 4 to 6 years, we would like to update our product in unison with the CCAP product. And with that, I'd like to hand it over to Claire. Claire, are you there? Great.
Yep. Thank you very much, Kasey. So I'm Claire Kudrowski, the Executive Director for the Maine Library of Geographic Information. We affectionately call it the Maine GeoLibrary, and when we're really taking notes, it's the Maine GeoLib. So I just have a couple of slides here to share with you. And I always learn so much every time I hear these presentations on land cover. I don't have the strongest background in land cover, so it's always very interesting to me. I've always danced around it. So Kasey and Nate, thank you so much. I learned quite a bit. So this year, the Geo Library Board voted to invest in updating the land cover data set, and we've begun a campaign to develop this new high resolution land cover classifications using the latest inputs of LiDAR and aerial imagery. Our intent is to have the entire state of Maine processed so that we have one data set. As you know, current, accurate land cover information is usually a foundational data set that's used to address a wide variety of management issues. We just saw that the last time this data set was developed specifically for Maine was back in 2004. And with today's technology, we can obtain much higher resolutions. So we're seeking to fund in partnership the development of a multi-resolution comprehensive set of land cover products for the state. And these are going to provide an appropriate level of detail for a wide variety of applications, as well as, set themselves up to be easily updated in the future. And the data development will include a spatially detailed 1-meter land cover map and a 10-meter land cover map that also includes detailed forest type information. So our goal is to, fund this effort is $701,000, and we're currently at 51% of the way there, with generous support from NOAA, the Office of Coastal Management, the Intelligent GeoSolutions Group in the University of Maine Center for Research on Sustainable Forests, the Maine Department of Transportation, the Nature Conservancy, and the Maine GeoLibrary. So, you know, we currently have $360,000 and we're still looking for $341,000. And if we can get this done next year, then that schedule that Nate mentioned earlier in his presentation, where we're taking advantage of updated orthoimagery in 2021, that means that we could actually have data in the summer of 2022. And like I said, this impacts the entire state, not just a portion, not just, you know, a certain county or a certain region. So from my perspective of being the executive director with the Maine GeoLibrary, it's very exciting that it would benefit the entire state. So I'm hoping that you are interested or know of folks that you could reach out to, of agencies, nonprofits, municipalities, you know, whoever that would like to participate, because, you know, many hands make light work. If you could move to the next slide, please. So many hands make light work, and, you know, every little bit counts. Just think, oh, I'm not a big, you know, there's no way that I could be a big donor. That's not the case. Every little bit counts as we inch closer. And you can see that we've really done quite a bit, you know, in today's economic climate. We still have done quite a bit to get there. So I'm hoping that if you have ideas, you have suggestions, that you'll reach out to me. Naturally, I'm sure that I speak for everyone that has spoken today, NOAA and the University of Maine. You can see we like talking about mapping, and specifically in this case, land cover. So I'm sure they would be glad to hear from you if you want to reach out and talk about these processes. So once again, just contact us if you're interested in contributing or learning more about this program. Thank you.
Thank you, Claire. And thank you, Kasey and Nate, for those presentations. I think you painted us a very nice, clear picture of your capabilities and the vision behind this entire effort. We're at the point in our Lunch and Learn where we could start tackling a few questions. A couple have been rolling in. Patrick has a few, and I've got a few here as well. Why don't I lead off with one question for Nate, just to address one that came out earlier, and then Patrick, maybe you could provide a couple of yours. So Nate, we had a question about the data you referenced for York and Cumberland counties. Could you just provide a more specific date when those data might be available, and any other considerations with that?
Sure. I guess I did kind of tease folks with that, and I was so focused in on the current proposal that we're talking about that I didn't really let you know when that data would be available. So those two counties, the draft data that we've been working on for a little while now, that should all be complete this spring. So by March of 2021.
Great, thank you. Here's a question for both Nate and Kasey. Do we need LiDAR data or other ancillary information in order to produce a high quality land cover and forest type product statewide? I think the question might come because we do have LiDAR data for most of the state, but it's spotty and some of it is older. And so we were wondering whether or not that is going to present a challenge, and does that lead to, you know, increasing coordination for some of these different data set collects in the future?
So I'll speak that from the 1 meter land cover side. Certainly having high quality, up-to-date LiDAR information is a big advantage and highly useful. We do not always have that available to us, so we've become pretty adept at working around what we do have and making the most use of what's available. So, you know, one of the things that we've found that we can do is utilize places where that data does exist to help us in developing some of our training for the more deep learning AI classifiers that we're using and apply those in areas where the data doesn't exist. Might take us a little bit more work to clean up those areas a little bit, but typically we're able to get to a pretty good product even if we don't have that complete coverage.
And this is Kasey. So from a forest typing perspective, certainly LiDAR data have potential to provide a meaningful assist in that. But I think generally speaking, you'd have to say that the multispectral satellite imagery provides much greater information content that's suitable for that task. So I'm not really, I don't see enough of an advantage to warrant the additional costs of processing just to obtain forest type classes. It's also worth noting that when you're talking about that kind of classification or prediction problem for forests, you generally obtain better results by looking across a slightly larger unit of ground cover, right? So something in the neighborhood of a 10 or 20 meter pixel is actually quite good for forest type mapping. And if you look at pooling data over smaller pixels, I mean, that's what you have to do. You have to pool those data and look at polygons instead of pixels. It's certainly doable. There are advantages and disadvantages to either approach. But I would argue that 10 or 20 meter satellite imagery, particularly multi-temporal satellite imagery, is kind of where it's at for that forest typing question.
So we've got a question from Justin. He's wondering how we can get feedback on forest map classes.
How you can provide feedback? Is that? Okay, yeah, well, certainly you could email me directly. My address is on screen there. You could try giving a phone call, although that's my office number, and I don't necessarily check that too frequently these days, working from home, but certainly email me. I think we need to develop a little more of a web presence with respect to what we do and how we're gonna go about doing this, but I would certainly be interested in hearing some feedback. We do have the capacity to alter our forest typing plan at this point, you know, until the work is really rolling, we can certainly look to incorporate some feedback.
Great. We also had another question. How does the mapping you propose compare to that from others, such as Sylvia Terra?
Right. Well, I mean, I think what we're proposing here is a general forest type scheme that's suitable over scales, you know, like a statewide kind of scale. So what you could obtain from Sylvia Terra or other vendors would certainly be more detailed and, you know, and more suitable for smaller spatial scales. What we're talking about here is a forest typing product that can be integrated with that 10 meter land cover product to provide a more general purpose product that still provides enough detail to suit a bunch of different use cases. Certainly things like, you know, forest health monitoring or risk assessment. We would like to develop a product that is suitable for a lot of applications in that realm. Certainly, if you had more detailed information on forest composition and forest structure, you could do a better job for certain applications. But obviously that brings with it greater challenges and greater cost. Along the lines of what Nate was describing, we do have the capacity to produce more detailed information for those who are interested. It would be something that would have another cost associated with that. Through the university, we're not exactly commercializing products in the traditional sense of spinning off business ventures here, but we do need to cover our costs of data production to a certain extent. So producing that more finely resolved information does bring with it added cost.
Thanks, Kasey. It looks like we have time for a couple more questions maybe. And I've got one that's related or similar to the question you just answered. This one is back to Nate. How do the standard CCAP wetland classes compare to the National Wetlands Inventory? does one leverage the other? And yeah, I guess that's the question. Thanks, Nate.
Yeah, so CCAP maps about 9 categories of wetlands, several palustrine and several estuarine categories. It's very similar to some of the hierarchy that might be available in the NWI data sets, but obviously, with all of the various inundation and hydrologic modifiers that NWI can have, they can have hundreds or thousands of possible combinations of categories. So we're not mapping to that level of detail of what's associated with that full suite of NWI. It's more of like an NWI light, say, and you could look at the CCAP page to see the categories that we map and the definitions that are associated with them. That said, both products do leverage one another to some extent. So typically, NWIs utilized some of the CCAP level 30-meter change in the past to flag for themselves areas where their mapping is more likely than not out of date and in need of updating. And CCAP at both the 30-meter and our high resolution level, we do take a lot of advantage of the existing NWI data sets to start the process of mapping our wetland categories. Even if that data is out of date, it still typically provides us a good starting point that we can then make some tweaks, edits, and updates to.
Excellent, thank you. Patrick, I think I'll turn it over to you.
Sure. I see a question here. How are you defining recently disturbed time frame? Maybe that's a follow-on to talk about.
Sure. So the thought was to map recent disturbance dating back to what would have been the most recent CCAP product of 2016, up to whatever the production date ultimately is for this set of products. Presumably 2021, I think, is what we're thinking right now. So that's kind of an arbitrary decision. To some extent, we do need to. Just from a data production standpoint, we need to identify recently disturbed areas because we utilize multi-temporal data sets. We use satellite imagery that's acquired throughout the growing season, and that's specifically to leverage differences in phenology between tree species. And we oftentimes have to pull data from multiple years in order to get enough cloud-free data to work with. So I would anticipate pulling satellite imagery from, say, two years, perhaps 2019 and 2020, let's say. So if we're using imagery from those 2 years, we really kind of need to map out disturbances that occur across that 2-year period because we're not going to obtain reliable predictions in those locations just because the ground conditions change during that mapping period or during that observation period. So to a certain extent, we have to map disturbance. Now, there's an argument to be made to go back a little further in time because stands that have been recently disturbed, you see a lot of spectral change, a lot of rapid spectral change, particularly in Maine. So predictions will be less reliable under those conditions. So there are a few arguments to map out a longer time frame of disturbance than just a couple of years. But it's a bit of an open question. I'd certainly be open to feedback whether or not 2016 makes sense to people. If there's a 2019 CCAP product, perhaps it makes sense to map disturbance from 2019 through 2021 and leave it at that.
Okay. Great. Well, that's really good information. That's about all the questions we have. If we missed any questions, I'll pass them on to our presenters and make sure that they follow up with you. Amy, do you have any closing thoughts?
No, Patrick, I just wanted to thank you and MEGUG for hosting us today. We are, in the middle of this project right now, and we are still looking for feedback from end users and people who want to participate in actually funding the project. So you've got all contact information. Please don't hesitate to reach out.
Excellent. Thanks so much to all of our speakers today. Thank you all that attended. And as I said earlier, we are looking for other topics for our virtual lunch and learns for 2021. So please do reach out to us if you would like to present. Everybody have a great rest of the day, and we'll talk with you later.